Hi, my name is Rachel Shed and I am the Head of Subject for Applied Science. Thank you for coming and listening to this today. So I'm going to go through how the BTech Level 3 National Extended Diploma in Applied Science works, talk about our entry requirements and a little bit about the course and the units that you will study if you choose to do this diploma with us at Suffolk 1. So firstly, why would you choose to do a BTech? One of the main reasons most students choose to do a BTech is the opportunity to be assessed in a variety of ways. So there are exams on the BTech in applied science. However, most of the units are internally assessed, which means that you'll be assessed via assignments and coursework. And those assignments and coursework can be presented in a lot of different ways, for instance, lab reports, and booklets, etc. I will go through later on more of the ways of how they can be assessed, but it's got this nice blend of both exams and assignments. So a lot of students that don't feel confident in exams, especially over the last couple of years where exams haven't really gone to plan as they normally would due to COVID, often choose to do a BTech because it allows them to actually be able to get their qualifications without heavily relying just on exams. The other nice thing about BTech and exams is that exams can be resat. So quite often the exams are undertaken during January, and then there's the opportunity to resit in May/June, depending on when BTech release their exam timetable. What this means is that students can actually keep their highest grade, and students can then improve their grade. So if students don't do as well as they wish, or maybe they're one or couple marks off the next grade boundary, there's the opportunity to resit later in the summer to try and get that next grade boundary. The other really good thing about BTech is that you develop industry related skills. With the BTech Extended Diploma in Applied Science, everything actually is quite heavily practical. What that means is that there are assessed practicals, and we have to sign off students to say that we've seen you do certain skills, which are exactly how they would do it in industry. So you're learning all those scientific skills, exactly how they would be done in a lab, for instance, outside of college. And it means that there's this really nice blend of both practical and theoretical lessons, and tutors will use practicals to help support theoretical lessons where they can. Now, in terms of the content, it is very similar to this, and it's the same level as those in A levels. So because you were doing a bit of biology, chemistry and physics, there's a little bit of A level biology based content in there, same with A level chemistry and same with A level physics. Okay, so it's the same ability that you would need for both. And the other reason why people choose to do a BTech is to do with progression, and you can progress on to university, employment or apprenticeships. So a lot of students will use this as a different route onto university, because it's the equivalent of 3 A levels, and they'll go on to do science-based degrees, whether that's a bit more sort of biology, chemistry or physics based. Some use it to try and secure employment within the science related industry, so within labs, and then some will do the BTech and look at doing higher level apprenticeships. So in terms of entry requirements, you need at least 5 GCSEs graded 9 till 4. Now, in that 5, the following must be included: GCSE Science, English Language and Maths. So in GCSE Science, you need at least a grade 4 if you're doing your combined or your core and conditional, or if you did all 3 separate sciences, so GCSE Biology, Chemistry and Physics, you need at least 4s in 2 of those. You need a grade 4 in GCSE English Language. Now, some of you will be doing English Literature as well, but it is the English language that we are looking at specifically. And then we would like a grade 5 in GCSE Maths. Now, the reason why we ask for a grade 5 in Maths is the sheer amount of calculations and working with formulas and having to rearrange them for the exams, but also for other units. Okay, so there are a lot of mathematics mathematical content across the units, including things like stats tests, having to do standard deviation and t-tests from scratch, as well as just having lots and lots of formula that you need to know how to work with across biology, chemistry, and physics, especially in the exams. The exams have a lot of mathematical content within them, so that is why we ask for a grade 5 in maths. If you were to get a grade 4 in maths, just shy of our 5, then we would look at this on an individual basis based on the rest of your GCSEs. Okay, so if you fell slightly shy of that, then we would have a discussion and have a look at the rest of your grade profile before making a decision. So the 2 years make up the equivalent of 3 A levels, and these are the units that are currently provided on applied science over the 2 years. So there are 7 units in year 12 and then 6 units in year 13. Now, the two in bold for each year are the exam-based units. So in year 12, there's this unit, Principles and Applications of Science, number 1. And this is an exam. It's actually made up of 3 exams. So there is a biology exam, a chemistry exam, and physics, each of which are 40 minutes long. The biology content covers things such as cells and organelles and tissues. Chemistry is more focused on the periodic table, looking at trends across, and there's quite a lot of calculations, including mole calculations that are included. And then the physics there, it's all about waves, looking at things like reflection and refraction. There's lots of calculations within that as well, and also looking at the electromagnetic spectrum and how that can be utilised in communication, so things such as wireless and Bluetooth. The other exam-based unit is the science investigation skills, and it's got made up of 2 parts, so it's known as a set task. The first part is where you will get 45 minutes to review some data from a practical that has been given to you. So you'll get 45 minutes to go through, make sure that you understand what it's all about, and then later that day you will then sit a 1.5-hour exam on that. Now, the exam itself is made up of kind of 2 parts. The first part is all to do with the data that you had been given about this practical. So the first question is that you need to draw up a table of results and work out averages. The second question is that you need to plot a graph of the data. And then the rest of the questions are more sort of generic scientific method about variables, so the independent dependent variable, control variables, observations, visible observations that you saw, not just the data, looking at reliability and accuracy. So it's all very sort of generic to do with that practical, and there might be some theory questions. So for instance, if the practical was about enzymes, they might ask you how different factors such as like temperature and pH affect how enzymes work. The practical may be biological, chemical, or physical based. So it could be based on diffusion, enzymes, or plants. It could all be about fuels or specific heat capacity, or it could be about circuits. So it entirely depends on the year, and they change up. And the second part to this exam is that you have to plan a method for an investigation that they give you, and they also give you another method and results for another practical, and you have to evaluate that. So you have to say what's good, what's bad, what needs to be improved. And all the rest of the units are assignment based. So practical scientific procedures and techniques is a chemistry based unit. It's made up of 4 assignments, and it's very practical heavy. You have to do some titrations, colorimetry, calorimetry, and then some paper chromatography and thin layer chromatography. And your assignments are about writing up those experiments. And then the last assignment is about looking at the skills that you've developed, not only just practical, but more those softer skills. So how you've worked with people, communication, research. So how your skills have developed over the course of that unit. The next unit, Investigative Project, is also quite practical based, but this time you get to choose an area that you are interested in, and you'll have to do that practical, and then you will write up that practical as almost like a big lab report, but over 3 assignments. You also get to do a literature review as part of that, which is really good because normally you're not actually exposed to literature reviews until you go to university. So normally this is something that you would do sort of second, third year of university, but we get you to do it now to learn it as a skill, and that really helps students because actually then it's not something completely new when they go to university. Medical physics is all about different applications and looking at things such as x-rays, ultrasounds, MRIs, lots of different techniques used within the medical world to help diagnose diseases or things like fractures, and looking at who can use them, who can't use them, the principles behind how they actually work, and then looking at health and safety within that. There's then a forensics unit, forensic evidence collection and analysis, and this is one that I teach as this is my background, and this is where we do kind of several parts to it. So the first part is that we actually process a crime scene, so you will have to decide what method you're using to search your crime scene. You'll have to collect and photograph evidence in situ. You'll have to then package it, so using the correct packaging for different types. And there will be evidence that are more biological based, such as hair, more chemical based, such as drugs, and more physical based, such as things like tools and weapons, and also like footprints and things like that. So we cover lots and lots of different types of evidence. Once we've done the crime scene, the next stage is to bring it all back to the lab, and where you're going to then analyze that. So for hair, we would use things like microscopy, same with fibers, um, drug testing. We use something called a Marcus reagent, and we look at color changes. So depending on the type of evidence that we're working with, we will do lots of lab-based practicals for it. And then the last part is about how to write that up, and actually how to be an expert witness and how to give testimony about what you've found in terms of your lab analysis. So it will be a day of get to dress up smart, ready for court as such, ready to present your evidence. And the last unit for year 12 is disease and infections. So this covers lots and lots of different types of disease and infections caused by many different pathogens, such as bacteria and viruses and protozoa, and looking at how diseases and infections spread, how they can be treated, looking at the effectiveness of those treatments as well. In Year 13, you also have 2 exam-based units. First one is Principles and Applications of Science number 2. It works in the same way as the first one in Year 12. It's made up of 3 exams, 1 biology, 1 chemistry and 1 physics, but this time rather than 40 minutes long, they are 50 minutes. The biology content includes things like the cardiovascular system, respiratory system, urinary system, and cell transport, whereas the chemistry is a bit more focused on organic chemistry, and the physics is focused more on things like thermodynamics. So once again, lots more mathematical content within those as well. And the second exam is a set task, which is contemporary issues in science. Here you are given 3 different articles, and you get 6 hours of research to do with those articles. So you get 6 hours where you'll get to read those articles, you get to make notes, you get to make 4 pages of notes on those, and those 4 pages of notes are then brought into the exam with you. So the exam is a 2.5-hour exam, and there are 5 questions based on the 3 articles that you have been provided with, but they are a bit more essay style questions, hence why the longer time of 2.5 hours for it. And in terms of assignment-based units, you do one called Laboratory Techniques and Application. This is all about working in the lab, looking at health and safety, looking at databases that are used within the science industry, but also some practical work. So you actually get to synthesize, so make aspirin from scratch and test its purity, and you also get to make ethyl ethanoate, and that is one of the active ingredients in nail varnish remover. So that really strong smell when you open up nail varnish remover, that is ethyl ethanoate. So you get to make that and test its purity too. You also get to do a really specialised unit in genetics and genetic engineering, so you get to learn all about the structure of DNA, look at mechanisms of DNA replication, um, and then actually do some practical work where you'll get to extract DNA, you get to amplify it, so you get to make copies, make more copies of that DNA, and then run gel electrophoresis to try and actually visually view the DNA that you've recorded. And the last part of that unit is all about genetic engineering, looking at lots of different applications, including stem cells. Another unit that you do is microbiology and microbiological techniques. This is made up once again of quite a lot of assessed practicals, but you do some theory looking at lots of different microorganisms such as bacteria, viruses, protozoa, fungi, look at how they're classified and their structures. You get to do some microscopy work and learn how to calibrate a microscope and learn how to properly undertake biological drawings of what you view underneath the microscope. And then more practical work, so working with bacteria, for instance, learning how to prepare and make up all the different types of medium that you could grow bacteria on, such as solid and liquid, looking at different techniques that you would use to inoculate bacteria onto solid media, so lawn plating and streak plating, looking at different ways to measure growth of bacteria, such as hemocytometry and colorimetry. Get to do some practical work in looking at different factors that affect growth, such as pH and temperature. So lots and lots of hands-on work with bacteria, especially. Because we can't see work with things such as viruses in the lab, but you can look at things like fungi underneath the microscope as well. So quite hands-on, and good unit, especially if you're thinking of doing something science-based at university, especially if it's something maybe a bit more biology-based. Quite a lot of universities offer microbiology-based units, even with degrees in things such as forensics, they do microbiology units. And the last internally assessed unit is material science. So this is a bit more of a sort of chemistry based unit, but it's all about different materials, and using those in different applications. So for instance, nanotechnology, and the ways that nanotechnology can be used, especially within medicine, and how those uses are changing and progressing over the years. So all of these units then make up your equivalent to your 3A levels. So how are you assessed? So with this, obviously you're going to have some exams, and for those exams unit you will also have some tests, sort of end topic mini assessments throughout before the lead up to the exams, and including lots of mock exams as well, so you get used to how the questions are framed and kind of get all that practice in. But for internal based units, so coursework, it could be that you are to do lab practical, then you need to write that up in a lab report. It could be that you're asked to write some essays, or potentially put together a PowerPoint for a presentation. It could be that you're asked to write a report or a leaflet or a poster on a certain topic. So depending on the unit will depend entirely how you're assessed, and each unit will try to use different methods of assessment throughout the different learning aims. Okay, so most units will have between 2 and 4 pieces of coursework for that unit that then helps to make up your grade for that unit, and they'll try to use different methods throughout. So how are you graded? So for each unit you can achieve pass, merit or distinction. Now for coursework units, each assignment will have certain criteria on there. They'll have some pass, some merit and distinction criteria, and there will be a number of pass criteria, a number of merit and a number of distinction criteria that will make up that overall unit. To achieve an overall distinction for a unit, the highest grade that you can, you'll need to achieve all of the pass, all of the merit and all of the distinction criteria. If you were to miss one of the distinction criteria, then unfortunately you would then come away with a merit overall. And so for a merit, you need to complete and achieve all of the pass and the merit. And say for instance you missed one merit criteria, then you would only achieve a pass overall. What then happens is that you're then allocated some points based on what grade you got for that unit, and then all the points are added up from all 13 units, and you get given a grade. Um, Grades can run from pass, 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 all the way up to triple distinction star. So the example here of distinction, distinction, merit, that tends to be quite a common one. Most universities ask for DDM or distinction, distinction, distinction. So most students tend to kind of aim for those grades because that's what they need for university. However, every single year you do have those students to achieve those top grades of triple distinction star. So it is definitely doable. And when you then achieve your overall grade, that's then worth a certain amount of UCAS points. So if you are looking at universities, some universities will say they want a specific grade, or some will say they want this many UCAS points. And you can then look up online, look for a BTech UCAS tariff converter, and they'll then tell you that this many points is worth this. So on the right hand side, this is the amount of points that you need to get this certain grades on the BTech Extended Diploma in Applied Science. So with this, because you're doing assignments all throughout the year and you keep it on track, it's really easy to see how those points start to add up and what grades you're looking like you might need to achieve. So for instance, if you are falling short of something that you might need for university, then we can have a conversation and say, right, this next unit we want you to aim for a distinction, for instance, because you need some more points. On the left hand side are the points for the internal and external units. Okay, so each, in terms of unit size, the 60 GLH, which stands for guided learning hours, is some of the optional units that we pick, whereas 90 are the mandatory coursework units that you have to do as part of your course, but you get given a set amount of points. So for a pass, it would either be 6 or 9 points, for a merit, 10 to 15 points, and for a distinction, 16 to 24 points. And then these points will then all start to add up to help you give you that total on the right hand side. And then in the table below are the points available for the external units. So our 90 would be, for instance, our unit 1, which is that biology, chemistry and physics exam, whereas the 120, an example, would be the unit 3, the science investigation skills. And points work slightly differently here. So you don't just get a certain amount. So for instance, for a pass, you could get anywhere between 9 and 14 points or 12 and 19 points, depending on your level, if you've got a lower or a higher level pass. For merit, you could get anywhere between 15 to 23 points or 20 to 31 points, depending on if you've got a lower or a higher merit. You can also see that there is a grade for external units called a near pass. Okay, near pass means that you have nearly passed, you haven't quite passed. However, you can still achieve your extended diploma if you achieved a near pass in an external unit. So long as you don't achieve a U in an external unit, then you can still get it. Obviously, we make sure that students don't just get a near pass, and we obviously want them to do the best that they can. However, it was brought in just as a kind of safety net for students, just in case they didn't get their passes. So this makes up your programme for the extended diploma. Hopefully we will see you at interview, and if you have any other questions then you can ask then, and hopefully we'll see you in September. Thank you for listening.